Hi, I'm Chris Wilson. I'm a developer advocate on the Chrome team.
And I'm Jan Linden. I'm a product manager on the Chrome team.
And we're here to update you with where we are with web audio and some of the exciting things that have been happening there lately. I wanted to start by showing a few demos that I've been building over the past few months, and we'll get into some of the new features from there. So let's go take a look at my computer here. And you can see I have this web page up. It's webaudioDemos.appspot.com. This is kind of where I dump everything, so it doesn't mean it's polished or finished or great, but it's usually pretty interesting at least. And probably the most exciting thing since the last time we talked back in August was we have live input now. Like, we can get a live audio input into the web platform. So you may remember I did this neat little vocoder application. Let's zoom it up a little bit. Oops, not that much. That takes a sound, takes a voice or any other sound, and vocodes it. So you should be hearing, hopefully, some... there we go. And I built this back for Google I/O before we had live audio input. But the process it's going through, this vocoding process of like analyzing frequency bands and applying those to a different sound over time, it actually works in real time. All of this is happening in real time. So when we finally got live input working, it actually took me all of about half an hour to get it up and running on the vocoder. I just had to put in a little button to turn it on. And of course, we have to ask if it's okay if we use your microphone, because we don't want people spying on you or listening in on you. But once you do that, you can actually hear that I'm talking into this. And let's crank the gain up. It's a little weak here. There we go. And now I can just give my entire talk in the vocoder for the rest of the time. And mess around with pitch. Just, okay. All right. I've been told that's not a good idea, so we'll skip that. But kind of neat for the vocoder. But this also means it's quite easy to build other applications. The next thing that I did was immediately took a bunch of the effects that we'd been talking about, just things like delay and reverb and that sort of thing, and made an application that lets you switch between them, so you can hear what they sound like. You can apply different effects. It's a little zoomed in here. And this also meant that I could start playing with more complex effects, things like flanging or chorusing. And these effects actually take a fair amount of plugging together of audio nodes and doing some tricks with audio params. And there's also my personal favorite, the octave doubler effect, where you can hear a sub-octave in, which is an effect Chris Rogers came up with. It's really kind of neat to analyze how it's done. But this also means you can do things like audio recording directly. So I threw this app together. All it does is show a frequency analysis of the current audio input. But at any point in time, I can just say, I want to start recording. So I click record, and I get a little red button. And then when I'm done recording, I can see a waveform analysis, and I can download it to my machine immediately. And then I have a wave file. I can play back the wave file. Recording. So I click record, and I get and you can tell it's recorded the bit of sound that I had there. This is a very, very small chunk of code. All of these, by the way, are up on GitHub, so you can go grab the code and play around with them and look at them.
So, Chris, can you explain how you record to disk? Because that's actually something that people have a lot of questions about.
Yes, it is.
How to do that.
So this is an interesting one, because this is actually taking several different pieces of code, several different library functions, and plugging them together. The first one, of course, is just grabbing user media, so getting the live input, and pulling it into an audio node, doing a frequency analyzer on it. So I draw my own little frequency analyzer at the top of the screen that I pulled from some other code. I wrote a library that does the audio buffer display at the bottom. But the real-time recording part is actually done using a JavaScript node. And the JavaScript node basically just sits there and collects buffers and stacks them together. And then when I say that I want to download it, there's actually a function in this library that will encode that. This is a library called Recorder.js. It's also up on GitHub. It's pointed to from my repository for this app too, so you can go find it and play with it. It only only encodes into WAV file format. It doesn't do compression. It doesn't try to do bit reduction or anything fancy to try to get it into an MP3 file or an Vorbis format or something and do a little bit better than that. That will come, I'm sure, but it's going to take a little bit of time to do good encoding in JavaScript.
Yeah. We can actually, we'll talk about that a little bit later when we come to some of the new stuff coming in Web Audio API, but when offline mode is coming, that will help in order to do
Absolutely,
these things.
absolutely, yeah. This was an interesting experiment, mostly because I got to play around with moving audio buffers around and actually grabbing the bits out of them and sticking them together and that sort of thing, which I hadn't really played with much before. And let's see, that kind of gives you a good idea of what you can do with with live input. The only other one that I added live input to, and this was actually the first one, is apparently not there. Ooh, never mind. So I'll fix that after the show, and you can check out the pitch detection. But basically, just doing an analysis on an input, and I actually used a real-time analyzer to do that instead of a JavaScript node. Although it's a very, very naive pitch detector. It's not something you should really use. It can barely tune my guitar into tune, although it does pretty well with whistling, which was kind of cool. Apparently I picked the right test sample the first time when I wrote it. But I wanted to talk too, in general today, just about some of the more advanced uses of web audio that are starting to solidify now that we've got a pretty mature implementation and we've been working through a lot of the issues. For example, the chorus and flanging effect that I have in the live input demo. I originally wrote the chorus and flange for Google I/O. And then I had to pull it out at the last minute because I was sitting there like a week and a half before the show, wondering why my code wasn't working, why I wasn't getting a chorusing effect. And finally I went to Chris and asked him to take a look at my code, and he dug through it and he was like, oh yeah, we have a bug here. And he had to, in the interim, it got fixed. So my code just kind of started working, and I had another input effect. But when you start plugging all of these things together, you can see sort of the power of what you can do with the Web Audio API. And I started saying, one of the things that I really wanted to, the reason that I really got into Web Audio was I was interested in synthesizers. I've always had a passion for synthesizers. And so I started building a synthesizer. This is kind of loosely based on the Moog Prodigy synthesizer architecture. It's not like a direct copy. It's not a recreation. So don't rip on it too much from that perspective. But I wanted to give something where you could actually play notes in it, and you could control a bunch of different parameters. So you can control filter and cut off and things like that. And all of the modulation effects and those sorts of things work. And I actually had a ton of fun building this. It took me about a week from beginning to end to build this sample. And the interesting bit to me was most of the time, actually like 90% of the work that I did here, 80 to 90%, was all user experience. The web audio part was actually very, very small. Like it was a small chunk of figuring out how to do a volume envelope the right way and figuring out how to connect the modulators and things like that.
Did you have to make any JavaScript nodes for any special
I did not, actually.
You could do everything in Web Audio.
I think the only application that I built thus far that I had to use a JavaScript node for was the audio recorder, because it really needs every bit. Like it needs every piece of information that goes past it. The pitch detector, really, if I wanted to do super high quality pitch detection, I might switch over to a JavaScript processor. But there is some latency because going into the JavaScript process is going to take some, is going to introduce latency and imprecision. But I thought this was a ton of fun. But of course, the interesting bit of web audio is how programmable it is, how much you can play with it. And I wanted to point out one thing that I did was after I'd built this, I realized I spent all this time building the user experience, and all these knobs are just jQuery knob UI. They're not I didn't like hand code all of the UI, and you can tell there's still some little bits that don't look great. But I realized that one of the parts I spent a bunch of time on was just a voice architecture for a synthesizer and building the keyboard and making it so you can play it on screen, you can play it using the computer keyboard. I have it plugged in with a MIDI polyfill, so I can play it with the little keyboard that I have standing over the side here, it's off screen, and then I can actually play it, and it sounds more like I'm actually playing music. But I wrapped all of that code together, and I have the super simple version of this, the template for a synthesizer, which you'll notice all of the UI is missing, and you can still play it the same way. But the interesting bit about this one is you can go in and grab the code, and it just has a voice object type. And when a voice is created, when I call new voice every time a new note gets played, then it pulls in, and we have code right here that just grabs can figure out what the frequency needs to be.
Can you bump the font up just one?
Oh, sure. We pump it way up. Obviously, I was in deep programming mode yesterday and had it down a little bit. You can grab the frequency for the note, and then you just create an oscillator in this case. Or maybe you want to, grab an audio buffer and figure out what playback rate to set for it. But in this particular case, all that I have is a sine wave oscillator, and then I create a pretty standard attack, decay, sustain, release envelope for it. And then at the end, I call note on, and that's it. Like there's no other processing in this particular synthesizer. It's a pretty straightforward one. But if I wanted to make this, a sample playback synth, instead of creating an oscillator, I'd create an audio buffer source node, connect it to an audio buffer, figure out what the right playback rate was to get it to play back at the right frequency, and you're off and running. So you can grab the synth template, plug your own code into the note on and note off parts, and really easily get up and running and have something that's playable and usable without having to go build the actual on-screen code and stuff like that.
Yeah. Wow, nice.
And of course, the other bit that I probably ought to mention is I've been working on making sure that works well on iOS as well. I've got my iPad here. I have the same page up and running, and you can probably hear it now. It plays the same way. And so I put touch support into it as well, so you can get some effects there,
Nice.
Get some additional device support. In fact, I think one of the interesting things to me too is seeing how touch and mobile devices is going to affect web audio as it rolls into there. The iOS implementation is really good. It has some parts of it that are still pretty challenging. I was talking with Jan right before this about Convolver node is still pretty iffy on iOS, and that I ran into some problems because I was using it for reverb on the synthesizer. But a lot of other apps are really easy to build, and the responsiveness of having a touch interface is pretty cool. I have one app in here that is called Touchpad. It's really kind of like my first mobile audio demo. All it does is it plays a sound when you touch, and as you move around, it changes filter parameters. So it changes the filter cutoff frequency as you drag down, and it changes the Q value as you drag across. So you can kind of close the filter and open it back up. And you can kind of whirl around. I'm just going to carry this around with me when I go out at night. And,
It can annoy
soundtrack, yeah.
Excellent.
So yeah, I think one of the great things to me is we're really getting to the point. I've been seeing a lot of other people's applications come out with web audio, in web audio too, and some interesting new things. There's some like Pedalboard.js, for example, that does kind of a framework for building effects, kind of effects chains and pedal boards, really.
Yeah. So you can just hook up your guitar and...
You can hook up your guitar and go, yeah. I really should have brought my guitar with me, but then I'd have to play it on camera, and that would have been kind of embarrassing. But, just plugging my guitar, I actually have a guitar. I used to have a guitar in my office all the time, and then I didn't for a long time. And now I've brought my electric guitar into work, and it sits there all the time just to plug into web audio and play around with it. Because sitting there and playing through all of these live input effects with an instrument is pretty cool. Yeah. Even cooler than
we should
doing voice
maybe
and things.
Talk a little bit about on the input on the latency that you get.
Definitely, yes. So, and one of the things that has really been a goal then for the whole time has been super low latency, right? I mean, that was one of the things that I know it was frustrating to me for a long time because I really wanted live input, but but the engineering team, and Chris in particular, is really passionate about having super low latency, like musically useful audio input, rather than just something that, you can get audio input, but you might have a lag time of, over 10 milliseconds or 20 milliseconds, or things that aren't super useful when you're trying to play a guitar through it.
Yeah. I actually did some measurements recently, and you can get down to 5 milliseconds from microphone in to speaker out, and with pretty standard hardware. And if you just use your Mac without any USB device or anything, you can. On my Mac, I got it to 9 milliseconds.
That's pretty good.
That's very useful. I mean, it's like having a speaker 9 feet away from you. It's that's very manageable.
It's really it's really it's nice to have such good feedback and such low latency, and be able to do something that's like I said, musically useful. That's one of the exciting things to me has been just working with such a low latency API, although it ends up bringing up new challenges too, and you have to come up with new architectures. Like, one of the things that I've been talking with people a lot about lately has been the concept of scheduling, and like scheduling musical notes as well as web audio, and then of course web MIDI events as well. And the idea of how you would go about building a system so that you sort of schedule ahead on the high precision timer, because you don't have events in the web audio space, in the web audio time, I should say. Like, you can't say, call me back at precisely this number of microseconds, basically, because JavaScript doesn't have that kind of level of precision in its eventing system either. So you have to sit there and say, you know what, I'm going to set an interval timer, and every 30 milliseconds I'm going to call back, or even less than that, every 15 milliseconds, which JavaScript can usually handle. I'm going to go play the next 20 milliseconds of events and set them up in the web audio event queue or the MIDI event queue. I think that'll those sorts of architectures are still coming, and I'm working on a demo for that, but I don't quite have it done yet, so I didn't want to.
Since you mentioned MIDI, I know another very passionate thing for you is to get the APIs for that.
Absolutely, yes. So MIDI is sort of the way that you hook up musical instruments, controllers. I have a whole pile of controllers on my desk at work. People always stop by and say, what do you do here anyways? Because I have all these weird things sitting there. And it's also used for things like lighting systems and other things as well. But it's not just, I have this professional synthesizer that I want to connect anymore. And to me, when I first started looking at web audio here, the thing that immediately was obvious to me was that it was super powerful. You could create these really rich musical applications, except the inputs were still like, go click on something on a mouse with a mouse, or go drag this slider. And I was like, that's horrible. I can't stand. Like, I like having physical things to touch and move around, and knobs and buttons and things. And MIDI is the way to do that. So I immediately said, okay, how do we go about adding MIDI to the web platform? And I became the co-editor of the specification. We now are in our second public draft. It's getting pretty stable. We've still got a few open issues, but we did bounce at 0 issues for a while there. And we're looking to get some native implementation, but I also wrote a polyfill for it that uses a plugin on OS X and Windows. And the plugin basically allows you to include this JavaScript library, and then just act as if the Web MIDI API is there. So you can listen for MIDI events, you can grab onto different devices, send MIDI outputs if you want, that sort of thing. So it's it really helps unlock the power of web audio to me. Particularly with things like the synthesizer. I mean, like, it's really hard, even with the computer keyboard, which is a physical button, to play anything that's really expressive. But of course, I can play it pretty expressively on my keyboard here. And because this was a replication of an old analog synth that didn't have a ton of controllers or anything, I haven't yet done things like velocity responsiveness and controller responses and that sort of thing. I have some of the things hooked up. You could tell you can play with the filters in real time and that sort of thing. But yeah, so that's kind of the lap around the newer stuff that we have.
So let's talk a little bit about what's coming up next.
Yeah.
So a few things I'm I'm aware of is the engineers are working on an offline mode, so which means that you can do processing not in real time, faster than real time if you want to, or sometimes slower than real time if it's really complex.
Right.
But and that, as we mentioned, will help you in doing, for example, encoding before you dump something. Somewhere.
Exactly. It's also nice for when you're building like digital audio workstation type software, because you can apply an effect and then just grab the audio buffer if you want to save it and not have to try to do everything in real time.
Yeah. That's a
yeah,
nice
I saw that there'd been a sort of trial implementation of that under the covers in Chrome for a while, but Chris added that to the web audio specification too, so you can read up on how to do it and go play with it in Chrome.
Yeah, and there is a new spec coming out pretty soon, I think, as well. And then the other big thing, and the input is part of this. So the input is done by hooking up to the get user media, which is part of the WebRTC efforts. And there's a lot of effort going on to hook up WebRTC and web audio in other ways, so you can actually take the input or the output from a web audio and connect that to WebRTC. And then, for example, if you have a video conference going on, then you can apply all these cool effects and then send it over there. And likewise, the next step is on the receiving side. Then you can do the same thing, or do analysis, or do spatial, or whatever you want to do on the receiving thing. So.
I've wanted for a while. I've wanted the ability to just hack into my Hangout and apply web audio effects, if for no other reason than taking that dynamics compressor and applying it to everyone in the room, because I'm on a lot of teleconferences with people from different locations, and invariably, half of the group is in a conference room somewhere and they're very quiet, and you have to listen and crank your volume up. And then there's the one guy who's sitting with a microphone right on his lips, and jumps in and blasts everybody out.
Yep.
It'd be nice to kind of tone that down just a little bit. But yeah, it's going to be really exciting. I can't wait to start applying, doing all my Hangouts in Vocoder mode or things like that. That would be kind of cool.
Great.
So yeah, I think, did we have any questions to answer from the queue? I can't remember. 1 second.
So we do have a couple questions on the moderator. So let's go ahead and get ready for those. One of them asked about performance. How much will a difference in implementation on different operating systems make? For example, a tablet or smartphone. And then second, obviously some operations require more power than others. What are the dangers in the current implementations?
Good questions. Yes. So of course, there are going to be differences in performance on different pieces of hardware. When we see that today, even depending on what audio hardware you have, you can get different latency, particularly. But even so, you'll see a difference in processing if you have to do a lot of conversions for buffers and things like that.
Yeah, you really have to optimize hard to get it to run well on the mobile processors, for example, and that's definitely room for improvement there. As you mentioned, the come-over node is not quite working as you like it to on iOS yet, but the combination of faster processors coming out there and more optimization will see that improve. But it's definitely a very important thing, and it's today it won't run perfectly on every scenario.
No, of course not.
And then operating system also has an impact, like doing things in Mac and Windows is slightly different, and there are things that can be done. And typically we get better performance on Mac, but still really good on Windows, especially when we can use certain modes there. And then Linux is obviously a little bit more spread in what you can get.
Of course. And mobile as well. I
mean,
the spread in hardware in mobile is just so broad, even outside of web audio, of course.
But the basic effects that you really need for doing like gaming, etc., without if you don't want to go too far, you should be able to do a lot of that.
I mean, one of the things that has been fascinating to me to understand has been one of the big values of web audio is simply cracking apart that process of downloading, decoding, and playing audio files, because with the HTML5 audio element, that's all wrapped together, really. Like, you can play separately, but it's not really a low latency play, and the download and decode is all wrapped together. And at least you can crack those apart, and just the value of being able to control when those steps happen is pretty important. And then when you're building gaming or even just like interactive sound for an application, making little beeps and boops when you roll over things or, select different options or whatever, that's actually really lightweight in terms of what you're doing with web audio, but it's very effective in terms of giving feedback to the user and having a more immersive experience. Yeah. Then there's, of course, the whole processing pipeline, and even doing some basic effects can be pretty easy, but once you start trying to really crank a lot of nodes together. I was kind of fascinated that Vocoder actually worked when I first implemented it, because when that's running in real time, it has about 400 audio nodes of various kinds active all the time and processing all the time, which I was sure it was just going to fall over. But it was doing okay, except every once in a while, as I was practicing my I/O slide deck, I would discover that it wasn't working quite as well as I thought. It sounded a little noisy. It wasn't really glitching, but it was kind of crackling or something. And then I realized that I was using the speaker notes mode, and it was actually instantiating it twice. And it only happened when I was like triggering it from the MIDI keyboard. That it was running both of them at once, but it was basically setting up 800 nodes and running them all at once on my poor little MacBook Air.
Yeah, so you still have to be careful what you're doing.
You still have to be pretty careful what you're doing. But I think for a lot of the basic things, it's actually not that complex. And if you look at things like the synthesizer that I built, for example, it's actually not doing a lot with audio nodes. It is doing some pretty solid processing. I need to go back and play with it more on iOS now that I've sort of narrowed down that the convolver is causing a challenge for us. But I think that in general, you'll see performance will continue to improve and be easier to manage. On the power issue, power to me is really very related in this case to performance and memory usage as well, of course. But I think that the fewer nodes you can get away with, the more lightweight you can make your application, the better you're going to be. But I don't think you're going to see some kind of huge power drain. No,
and when you look at these devices, typically nothing gets close in power consumption to the display and everything. So
exactly, yes.
It very often drowns in that. So as long as, but of course, if you're running at full speed for a long time, that will have an effect on power.
Yeah.
All right, so our next question. Jeff wants to know how he can make simple on-site effects, for example, distortion or pitch, with only one user adjustable parameter that the user could activate for streaming music on the site. And in terms of page load speed, what would be the best practice for doing this?
One effect that, with one parameter.
Yeah, so apply one effect to some music that's playing on their site. And what would be the best way to go about doing that?
Okay. Well, this is very similar. Applying one effect at a time and giving a small set of parameters. It's kind of similar to the audio input effects demo that I built, which I've meant to come back to and make it a little more componentized. But I think that it's a pretty good example of how to plug in a single effect and let you play around with a parameter or two. The one challenge is music playing back on the site. If you don't control the site, even if you can inject JavaScript, you can't always grab that audio stream. Like, you can't grab an audio stream off of a Flash object, for example.
But if it's playing in an HTML5 audio tag,
or even a video tag, you
can just use that as an input node to web audio, and then you can do whatever you want with it.
Yeah.
Awesome. And Lincoln from Miami wants to know, he'd like to use filters on real-time audio capturing from the microphone. Is it possible, and do you have a demo for it?
So real-time filtering of audio input. Actually, yeah. There's
That's one of the.
that's one of the effects on the live input effects demo is an Lfo filter. That this actually runs it on a low frequency oscillator. You know, actually, the telephone effect is a good one too. You can tell it's making my voice a little bit clipped here, but well, no, let's flip to the LFO one. Well, the telephone demo is a good place to start, just because all it does is take the user input audio, and it runs it through two filters, one to mask off the low frequencies and one to mask off the high frequencies. And so you only get the middle, which is typically what a telephone does. And the LFO filter, on the other hand, has this kind of weird bouncing effect where it's using a low frequency oscillator to control the frequency cutoff of a low pass filter. So if you listen to yourself through it, you'll actually hear it kind of bounce in and out.
Yeah, so that shows how you can vary it in real time.
Exactly. Yeah. And that's actually a really good topic. It's one that I'm going to come up with some more tutorials on and some videos on, is doing that sort of real time effects control using audio node routing into audio parameters, which I think is super powerful and not very well understood. In fact, I was talking to one of my coworkers yesterday who's done a bunch of web audio stuff, and he's like, "You can do that?" I'm like, well, yeah, that's how you do, chorus and flange and all these other effects that you need to have audio rate kind of controls over things on.
Oh, that's all the questions we have time for today.
Okay, great. Well, I think we'll close there, and until next time, that's web audio.
Yep.
Thanks.
Thank you.